So the first question is that the mass of a cyclist with the bike is given 90 kg. Okay, now we need to calculate the increase in the kinetic energy if the speed increases from 6 km per hour to 12 km per hour. So if the speed increase, then what will be the increase in the kinetic energy? So let's start with the first one. So what do we have? We have the total mass, which includes the mass of the cyclist and the mass of the cycle or bike itself, which is 90 kg. Now the velocity changes from 6 to 12, that is initial velocity is 6 km per hour. So let's convert it into meter per second. So once you convert this into meter per second, you will obtain 1.66 meter per second, and final velocity is 12 km per hour. So once you solve this, you will get 3.33 meter per second. So now it is quite simple. We need to find the increase in the kinetic energy or change in the kinetic energy. So it will be final kinetic energy minus initial kinetic energy. So this will tell us about the change or the increase. So half into 90, let's take mass half m common, so we will have v square minus u square. So 45 into 3.33 square minus 1.66 square. So after you solve this, you will find that it is approximately equal to 374.8, or approximately you can say that the increase in kinetic energy is approximately 375 joules. So this is the increase in the kinetic energy when the velocity increase from 6 to 12. Now in the second question, we have a block of mass 2 kg which is moving with 10 meter per second. Now it is accelerating with 3 meter per second square for 5 seconds. So we need to find the final kinetic energy. So in order to find the final kinetic energy, we will require the final velocity. Okay, so the first thing we will do is to find the final velocity. So the second question. So first of all, mass is given 2 kg, initial velocity is 10 meter per second, acceleration is 3 meter per second square for t equal to 5 seconds. Time is 5 seconds. So we can find the final velocity using this formula, which is quite simple. So 10 plus 3 into 5, so it will give us 25 meter per second. So now the final kinetic energy, okay, final kinetic energy equal to half m into the final velocity square. So half into 2 into 25 square is 625. So this gives us the final kinetic energy comes out to be 625 joule. In the third question, we have a box which is pushed by 4 meters across a floor, and the resistance that the floor is offering, or you can say it is like a frictional force, so it is 100 Newton. So how much work is done by the resisting force? So how much is the work done by the resisting force here? So answer solution third. So we know that the resistive force is given to us 100 Newton. Our displacement is 4 meter, and the angle between them is 0 degree. So the work done will be F as cos theta. So it will be 100 into 4 into cos 0 degree, which is 1. So it will come out to be 400 joule. In question number 4, we have a block of mass 5 kg and it is sliding down an incline of inclination 30 degree. And by how much? By 10 meters. So we need to find the work done by gravity. So fourth question. So what do we have? We have mass 5 kg. We have angle of inclination 30 degree. Okay, let me draw this. So this is approx 30 degree and the displacement that is happening is 10 meters. So displacement is 10 meters. Now there is a force on the block which is by gravity, which is mg. So this force is mg. So the gravitational force is applying some force in the downward direction, because of which the block slides down. Okay, so the force is mg, gravitational force is mg. So what will be the work done? Work done will be gravitational force into the displacement. Now Fs cos theta. Now one more thing, we need to find the angle between force of gravity and displacement. So if you notice, displacement is like this and gravitational force is like this, mg, and this is the displacement, okay, force. So this angle will be 60 degree. How? Because we know this is 30 degree, because this is 30. So because of which this will be 60, as this complete angle is 90. So the angle is 60 degrees. So what we will have, force equal to mg s cos 60 degree. Now let's put the values. Mass is 5, g is 9.8, displacement is 10, and cos 60 is 1 by 2. So what we will have after solving this, you will get 245 joules. So this will be the work done when the block is sliding down. Now the question number 5 is, there is a constant force of 2.5 Newton and it accelerates a stationary particle having mass 15 gram and the displacement of the particle is 2.5 meter. So we need to find the work done and the average power. So in the fifth question, what are the things that we have? So first of all, we have force, which is 2.5 Newton. We have displacement, again 2.5 meter. We have the mass 15 gram. Let's put it into kg. So it will be 0.015 kilogram. Divide this by 1000. So you will get in kg. Now work done. So what is work done? Force into displacement. Theta is 0 degree, by the way, here. Cos 0 degree. So it will be 2.5 and the angle is 0, so it will be 1. So it will give us 6.25 joule. The work done is 6.25 joule. Now we need to find the average power. So for average power, we need to find the time period, because power is work done upon time. So in order to find the time, we need the velocity, final velocity. So we can find the final velocity using work energy theorem. Okay, how? So the particle was initially at rest, so the initial velocity is 0. Initial velocity is 0. So using the work energy theorem, that is final kinetic energy minus initial kinetic energy is equal to the work done. So work done is 6.25 joule. It will be equal to half mv square minus half mu square. Initial velocity, u is initial velocity, it is 0. So 6.25 is equal to half mv square. So after solving this, you will get that v is 28.86 meter per second. So we have the velocity. Now how to find the time? So time can be found out by using this equation, v equal to u plus at. V equal to U plus AT. So time is 28.86 minus 0 upon acceleration. Now one more thing, acceleration is force by mass. So force is 2.5 and mass is 0.015. So 0.015, and this will go upstairs 2.5. So when you solve this thing, you will find that the time equals, or let's not solve this, let's have it like this only, 2.86 into we have done a small mistake here. This should be 2.5 should be downstairs and 0.015 should be upstairs. So if you solve this, you will get like this. So let's have it like this only for now. Now we have time as well. So work average power is work done upon time. So work done is 6.25 and upon time, so time is 28.86 into 3 upon 500. So 500 will be upstairs. So after solving this, you will get 36.1 watts. So this will be your average power. So in order to find the average power, we had to find time, and time was found out using this formula, and we found the final velocity using the work energy theorem. Now in the next question, sixth question, we have a particle which is moving from R1 to R2. The positions of the particle is given, R1, and then it goes to R2. Now the force was 5 Newton in the x direction and 5 Newton in the y direction. So we need to find the work done on the particle during this displacement. So the fifth one, so what are the things, sixth one, sorry, what are the things that we have? First of all, R1 is 2i cap plus 3j cap, R2 is 3i cap plus 2j cap. So remember, this is the x direction, this is the y component of y direction, this is the x component, this is the y component. Now the displacement is final position minus initial position, or the difference in the position vectors. Okay, so R2 minus R1, so this will be your final displacement or your displacement. So 3i plus 2j minus 2i minus 3j equal to I minus j. So the displacement will be this. So what is the work done? Work done is the force into displacement. So here force is 5i plus 5j, and it is to be multiplied by I minus j. So work done will be equal to, the I component will be multiplied by I component and j component will be multiplied by j component. So 5 into 1 will be only 5, and minus 5 into minus 1 will be, okay, minus 5. So 5 minus 5, so it will give us 0. So the work done comes out to be 0. So we do not need to do any work when we are moving the particle in such a way. Now in question number 7, we have a man who moves on a straight road with a block of mass 2 kg in its hand. Now he covers a distance of 40 meters with acceleration of 0.5 meter per second square. So we need to find the work done by the man on the block during the motion. So during the motion, the man is holding the block, so how much work done is done on the block? So answer or solution 7. So the mass of the block is 2 kg. The displacement is 40 meters The acceleration is 0.5 meter per second square. So ultimately the force that is applied by the man on the block is mass into acceleration. So the mass of the block is 2 and the acceleration is 0.5, so 1 Newton, and work done is force into displacement into cos theta. Theta is 0 degree. So this will be 1, displacement is 40, cos 0 degree is 1, so it will come out to be 40 joule. So the work done by the man on the block is 40 joule. So remember, this is the force. How? Because the object is accelerated by the person, so the acceleration of the person will be same as that of the block because they are moving together. Now in the question 8 we have a force which is a plus bx. So it depends on the position vector. Now the particle is in the x direction, a and b are constant, so we need to find the work done by the force during the displacement from x equal to 0 to x equal to d. So we are moving from 0 to d and we need to find the work done. So the 8th question, so F is equal to a plus bx. Now the position is changing from x equal to 0 to x equal to d. So here it is a variable force. Okay, the force depends on the position, so force the value of the force is changing. So for variable force we need to integrate. Okay, we need to integrate. Small work done will be calculated and then we will integrate that is small work done. So force into dx. So the integration will be 0 to w here, and here let's put the values. So f is a plus bx into dx. So here work done minus 0 equal to, now let's take them out individually. So now work equal to, here we will have ax which will have limit 0 to d, plus here we will have x square by 2 having limit from 0 to d. So once you put the limits, work done will be a d minus 0 plus b d square by 2 minus 0 square by 2. So the work done will come out to be a plus half bd, and d will be common. So after simplification you will find this as your work done. In question number 9 we have a block of mass 250 gram and it is sliding down at an inclination on an inclined plane of 30 degree with 37 degree with uniform speed. Now the work done against the friction as the block slides through 1 meter is, so we need to find the work done. So the 9th one, so here what is known, mass of the block is 250 gram, so in kg it will be 0.250 kg. Angle is 37 degree, displacement is 1 meter. So let me draw this situation. So this is 37 degree, the block is here, mg downward, normal force in this direction, it is sliding down, so therefore friction will be in this direction. So ultimately frictional force will be mu r, and this is mg sin theta component, this is mg cos theta component. So r is equal to mg cos theta and mu r is equal to mg sin theta. Okay, this and this. So let's put the value of r. So mu into mg cos theta equal to mg sin theta. we, by the way, need not do this because we need to find the work done only. So the work done will be work done against friction will be given by mu r, this is the force, into displacement s, and then cos. So the work done against friction will be like this. At the place of mu r we can write mg sin theta into displacement into cos theta. So the displacement is along this direction only, so we can take the angle to be 0, cos theta to be 0. This is different angle, let me use, this is different angle, this is different angle. Okay, so work done will be mg sin theta 1 into displacement, and theta 2 is 0 degree, so it will be 1, this term will be equal to 1. So we have this much here. So now work done equal to 0.250 kg into 9.8 into, now we have sin theta 1, sin theta theta is 37 degree. Okay, this theta is 37 degree, so sin 37 degree into displacement is 1 meter. So work done will be 0.25 into 9.8 into sin 37 is 0.6 into 1, so it will give us 1.5 joule. So the work done is 1.5 joule. Work done by the frictional force is 1.5 joules. So first let me write it theta 1. So this theta 1 is 37 degree, so mg cos theta 1, mg sin theta 1, this is r, this is frictional mu r. So we need to find the work done because of friction, so mu r into displacement into cos theta 2, this theta 2 is the angle between frictional force and displacement, so it is 0 degree because we are finding the displacement along this direction only. So this theta 2 is 0 degree, so cos 0 degree is 1, so this will be 1, and at the place of mu r we can write mg sin theta. Mg sin theta. So mg sin theta 1 into displacement. So let's put we have put all the values. Theta 1 was 37 degree, so sin 37 degree is 0.6, so this is the work done. Now in question number 10 we have a block of mass m and it is kept on another block of mass capital M, and the system rests on a horizontal surface. Now a constant horizontal force acting on the lower block produces acceleration of F upon 2 into m plus m in the system. So the force is applied on the lower block, okay, and the two blocks move together. So we need to find the coefficient of kinetic friction and the frictional force acting, etc., and the work done. Okay, so what do we have? We have a situation like this. So there is one block here, there is another block here, this is mass small m, this is mass capital M, force is applied on the lower block, okay, F. Now first of all, what is given? The acceleration is F upon 2m plus m. Now first thing that we need to find, so we need to find the coefficient of friction. So we know that the frictional formula is mu r. So let's try to draw the free body diagram. So there are this following forces, the upper object, okay, we are drawing the upper object, having mass m, so small mg downward, then reaction force by the lower body, then mass into acceleration and frictional force, kinetic frictional force. Let's say the force was in this direction. Okay, so if the force on the lower block is in this direction, then the force on the upper block will be in this direction. So now what we have here is that we know that frictional force is mu r, and here we can easily see from the diagram that ma is equal to frictional coefficient, frictional force, that is mu k into r. Now, or let me write r1. So ma is equal to, or we need to find mu k, so let's write in terms of mu k. So mu k is equal to r1 upon ma, sorry, ma upon r1. So it will be, we know that the acceleration and it is equal to, so r1 is equal to mg, so it can be ma upon mg. So mu will be kinetic frictional coefficient will be a upon g, so it will give us a is f upon 2m plus m into g. So this will be the value of coefficient of kinetic friction. Now in the second case we need to find the value of the frictional force, which is mu r. So it will be equal to, at the place of mu we can write f upon 2m plus m into g, and at the place of r we can write mg. So it will give us m into f upon 2m plus m. Next we need to find the work done. So work done is force into displacement, so therefore work done will be equal to mf upon 2m plus m, and let's say the displacement is d, so d, so the work done is mf d upon 2m plus m. So first we found out the coefficient of friction, of kinetic friction, and after that we found the force and the work done. Now in the 11th question we have a box whose weight is 2000 Newton, and it is slowly slid through 20 meters, so it is moved 20 meter on a straight track. So the coefficient of friction is given 0.2. Now we need to find the work done by the person, and also the work done when the person has chosen a value of theta which ensures him the minimum magnitude of force. So there are two situations: when the person is moving, applying the force horizontally, and when the person is applying the force at such an angle that the force applied is required minimum. So the 11th one, so what do we have here? First of all, weight is given 2000 Newton, displacement is 20 meter, coefficient of friction is 0.2. So in the first situation, what we will have, let's say this is the block, okay, this is the block, downward force is mg, upward there is reaction force r, then if the force is applied like this, so the frictional force will be mu r. So in this scenario what do we have? Actually this force is not applied like this, it is applied with some angle theta with the horizontal. So let's say this is some angle theta with the horizontal, okay. So this component of the force will be f cos theta, and this component will be f sin theta. So what do we have? We have, first is f sin theta plus r minus mg equal to 0. Now we know that f sin theta plus r, now mg, weight is given, which is 2000 Newton, so 2000, this mg goes here, okay, 2000 Newton. So this is one equation. Another equation will be f cos theta minus 0.2 r, because mu is 0.2, equal to 0. So this is another equation. So from these two equations what we will get f equal to 400 upon cos theta plus 0.2 sin theta by equation 1 and 2. Now the work done will be Fs cos theta, so it will be (400) on cos theta plus 0.2 sin theta into displacement is 20 meter, and now the angle between them will be cos theta. Let's write cos theta for now, cos theta. So the work done will be 8000 upon cos theta, and let's take cos theta common. It will be 1 plus 0.2 sin theta upon cos theta will be tan theta. So it will be 8000 upon 1 plus 0.2 tan theta, and even by more simplification you can remove this 0.2. So you will find that after more simplification it will be 40,000 upon 5 plus tan theta. So this will be your work done. Now we need to find the work done in the situation when the magnitude of the force that we apply needed to be that we need to apply is minimum. So whenever minimum maximum things are asked, we need to do differentiation. So this means d by d theta of the force has to be differentiated. This has to be differentiated, okay, and equal to 0. So from here tan theta will come out to be 0.2. So work done equal to 40,000 upon 5 plus tan theta. So it will be 40,000 upon 5.2 because this is 0.2. So it comes out to be 7690 joule. So in the case when the force applied is minimum, the work done is 7690 joule. Remember what we have done, we have used the formula. Let me again write it so that you can understand it properly. So it is mg this is f cos theta plus this quantity, okay, this quantity, this below this quantity needs to be minimum. So we have differentiated this quantity, and if it is minimum then its differentiation will be equal to 0. So using that we have found out tan theta and the work done.